Instead of having a parents table where I might have head of household and then children and then spouse, and we're going to have political and social problems with that, and even practical problems anyway. So let's just have a table of people. Now, I'm not doing this for politically correct reasons. It's actually just a better way to do it. So let's make our table. Hope I can keep track of what I'm doing here, because I might lose track of how many index columns I need, but we will deal with that when we come to it. So this is just a people table. And we're going to have our obligatory index column. And we will have, I'll make some rows here, and I'll start putting some people in there. And I'm going to put them at the end, or leave me room to add index columns, because I'm doing this on the fly. Okay, going to need a lot of these. We have a lot of people involved here. Okay, 2 more. Okay, and our index, this is our main index, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, and 14. Okay, let's try to rebuild those same exact families we had before. So our first person is Bill. Now, are we going to put these people in the database in the order they're in their families? Well, maybe if we're first putting the data in there. But if this is an old, mature database where we've had entries come in, entries go, people get divorced, people have children, children move away, this could be very randomized, but it doesn't matter. So what we're going to do, we'll put, let's put Jane down here at number 4. Actually, I want to move these over because I want plenty of room over to the left for index columns. So let's put Bill and Jane and their children. These could be very randomly put in the data set too, depending on when they were put in, when they got married, when, all kinds of things. So I'm just going to put, how about their children were Tommy and Susie? Let's put Tommy here. And let's put Susie down here. And then we have the next family we have. This is going to be now, how do we tie all these people together? Well, we have individuals. Each individual is going to have or not have a spouse. We're assuming everybody has a spouse here. Let's put another person in here. How about Jerry? He has no spouse. Does he have any kids? How about a kid called Alan? There we go. So we'll see how that links together later. So we have some other people there. No spouse for Jerry, but he does have a kid. Anyway, let's see what we can do. So each person is going to have or not have a spouse. So we'll put let's just leave that at spouse. We'll have another column for parent. Somehow I think I'm going to need one more column. We'll see if this works out. So how do we build a family now? Well, let's say, as before, Bill is married to Jane, so Bill's spouse will be Jane. Okay, so her spouse column should go to what? Remember, this column identifies the person uniquely, so that would be the number that identifies each person. So Alice in the spouse column would have a 0 pointing her back up to Bill. Bill would have, where's Alice? She's number 5, so Bill would have a 5 in his spouse column. Now, is one spouse better than another? Better leave it at that. So they have equal standing as being spouses, or is that spice? Whatever. So there's one set of spouses there. What's another set? I have notes over here so I don't lose track of what I'm doing. We have Joe and Linda. So Joe, where's Joe? Joe is tied to Linda. Linda's up there number 1. So Joe's spouse is number 1. And Linda is tied to Joe, who's number 10. So she's going to have a 10 there. And let's see, the last 2 spouses, we have George and Alice. So George ties over to Alice, who is 5. And Alice ties over to George, who is... Already got a mistake here. There we go. Jane, and Alice goes to number 9. There we go. I goofed it up, but I have it fixed. So Jane goes back to Bill. Bill goes down to Jane. Oops. And I have an error in my database. Can you get errors in your databases? Can you fix errors in your databases? You bet. You have to just go into a raw database manager, such as in MySQL and PHP. I use PHP-MyAdmin. And I can go right into the database and I can make corrections like this. And I've done it many times. But let's fix it so that Bill's tied to the right person. Bill should be tied to Jane. Jane is number 4, so that 5 should become a 4. There we go. Got that fixed. So we have all of the parents properly tied to each other. Ooh, what a mess, but you'll see how it works. Now we need to tie the children to the parents. So Tommy goes to Bill and Jane. So Tommy... I knew I was going to need another column. 2 parents. Each child has 2 parents. And are those 2 parents always in the same family? Not necessarily. In fact, I'm going to throw another kid in here just because I can. How about Sam? Make that Sammy. We'll see what he's going to do in a minute. So we have Tommy and Susie are tied to Bill and Jane. So Tommy goes to Bill and Jane. So Bill is 0 and Jane is 4. And once again, Susie, 0 and 4. That looks like a 9. 0 and 4. And then we're going to tie Sammy back up just to Bill. So Bill also has Sammy. So Bill is number 0. So Sammy goes to 0 and to 25, some other mother. So we have a mixed family, just like can really happen. And this may look totally useless to you. It's totally unintuitive for a human. But for a program and a computer, this is a great way to handle things because we just tell the program how to handle it. It's a repetitious thing. You write it once and it just does it over and over again. And so it has no trouble tying these together. So for example, let's say I'm putting data in. Let's say I put in the data for Susie. So I say Susie's father is Bill. And the computer says, oh, Bill is 0, so father is 0. And I say Susie's mother is Jane. And the computer says, oh, Jane is 4, so mother is 4. And so the computer handles all that. And so it's no problem building that index. And then when we go to grab a family, how do we do it? So let's go to Bill and Jane and build their family. So I tell the database, I need Bill's family. So they're not tied together anymore. So I say, I need Bill's family. And it says, okay, we'll go get Bill. Now who's tied to Bill? Let's go see if Bill has a spouse. Bill has, oh, yep, spouse column, spouse number 4. So we go, lower number 4 is Jane. Now let's see if they have any children. Does Bill have any children? Well, let's see. Bill is number 0, so let's see if there's any zeros in the father column. There is one. That would be Tommy. And go down, up, there's Susie, number 7. Well, we'll just put the Susie here. So Bill has children, Tommy and Susie. Any others? Let's see, we're looking for a 0 in the father column. Oh, yep, Sammy. Okay, how about Jane? Does Jane have any children? Okay, Jane has, let's see, Jane is number 4, so we go to the mother column and look for 4. Ah, yes, Tommy. And the computer could look and say, oh, Tommy is number 2 in both cases, so we can put Tommy as a child of both. Or not, but we'll do it now. And let's see, does Jane have any others? Jane, once again, is number 4. Look for another 4 in the mother column. Yes, there's Susie. Up. Susie is also the same number 7. So she's the same person, so we can make her a child of both. And let's see, once again, Jane is number 4, any other 4s in the column? Oh, okay, nope, no more Janes. Oh, look what we have here. Jane has 2 children with Bill, but Sammy is only Bill's child. Does that happen in real life? You betcha it does. So there's a way we were able to build the family, and we're able to actually use more information. We only have one table, so that simplifies the database, and everything is simply tied together with these index columns here to be able to build the whole family. So that may seem totally counterintuitive as a human readable thing. I could never use this table myself, but the computer being programmed to do that, and it's very repetitious and very quick, can go right through there and build that right up in no time. So that's the way I would build that particular type of table. Whenever I build tables of people, I learned fairly early in my database management that you don't want to have separate tables for different kinds of people, because there might be cross referencing, if you will. They might have, somebody might belong in both tables, and it starts to get redundant that way. A good example of that is for a business. A business has customers, but a business also has vendors. A business buys things and sells things if it's that kind of business, but any kind of business, a manufacturing business, Learjet buys aluminum sheets and sells jets. So you have both vendors and customers, but a vendor might be a customer. Let's say Learjet buys some aluminum sheet from Alcoa, and then Alcoa buys a Learjet from Learjet. So Alcoa is both a vendor and a customer. So instead of having a list of vendors and a list of customers, you have a list of both vendors and customers, because they might be both. So then I would have index columns of this is a vendor, this is a customer, or maybe an employee. Could an employee be a customer? Yeah, employees buy things all the time. Can an employee be a vendor? Suppose so. So one person can occupy 3 different roles, but building the table like this with indexes to decide who's who, then you can tie them together and make a much more efficient way of storing that data and actually retrieving the data. And that may be a mess for a human, but it's not a problem at all for a computer.